Our life is changing rapidly. Old reservoirs, which have been providing people with energy for decades, are about to exhaust. High demand for hydrocarbons leads us to develop more complicated structures: offshore, shale, heavy oil reservoirs, carbonates, and tight rock. New deposits are associated with new high-end techniques. The cost of solutions can be hundreds of millions and even billions of US dollars. Thus, the price for mistakes can be very high. The 3D subsurface flow model is the most accurate solution for field development planning. Industry-leading oil and gas companies invest heavily in 3D modeling. But there is a catch. Many software programming solutions are based on algorithms which have been developed 30 years ago, and applications have been written for the computer architectures of that time. In recent years, we saw a breakthrough in the realm of computing technologies. Processors with many cores, very fast memory, desktops transformed into powerful high-performance systems, and high-performance clusters became affordable even for small companies. However, in most cases, companies do not utilize supercomputers for reservoir modeling. The reason is that the reservoir simulators, with algorithms developed years ago, cannot take advantage of modern parallel computing. tNavigator, an interactive suite for 3D hydrodynamic simulations created by Rockflow Dynamics, is a game changer in hydrodynamic modeling. tNavigator's key advantages include high-speed computation, scalability on multi-core computers, and a license-friendly policy.
Also, we provide a possibility to online interactive visualization of computation process. It's allowed to engineer to visualize and reduce time for analysis of the results and for computation itself, just stopping unneeded computations if results are not good.
tNavigator calculates much faster compared to competitor solutions, and there are almost no limits for acceleration when computational resources are added. tNavigator provides improved workstation performance by a factor of 10 to 20 and cluster performance by factors of hundreds and thousands. In particular cases, the time of computation has been decreased from 2 weeks to 20 minutes. This is due to the use of a hybrid cluster algorithm which distributes the workload in accordance with features of modern hardware architecture. tNavigator efficiently utilizes all the features of Intel Xeon-based platforms, for example, multi-core architecture, hyperthreading, high-speed memory channels, and non-uniform memory access. In case the model is complex, but the project is urgent, the issue can always be solved by increasing computational power. Outstanding scalability of the solver in tNavigator allows for almost boundless reduction of the simulation time as the number of cores grows. Clients just need to choose a proper computational platform based on the specific targets and timeframes.
One of the challenges which we had to face was to actually keep the quality of customer support and actually do it not only in Russia but elsewhere. And for such a widespread client base, it's actually very important to use advanced technologies in support, like remote access to desktop conferences, web conferences, and we managed to actually continue to provide pretty much 24/7 support with very quick response time, and we think it's a great advantage which helps to actually to sell and spread the technology of tNavigator outside, basically worldwide.